moves along the x-axis according to position function, s of t equals t cubed minus 12t squared plus 36t for time in seconds between 0 and 8 seconds. A couple of things we're asked to answer. At what times is the particle at rest? When is the particle speeding up or slowing down? The motion of the particle's distance from the origin along the x-axis is given by this function. S of t equals t cubed minus 12t squared plus 36t. What would I know about the particle's velocity if it's at rest? It's neither moving backwards nor forwards. 0. So this is really asking me to do what? Set what equal to 0 though? Not the s of t, the v of t. S of t equals 0 would just tell me when the particle back where it started, at the origin. V of t equals 0 tells you when the particle's not moving backwards nor forwards. It's at rest. So let's find v of t and set it equal to 0. Take the derivative of t cubed minus 12t squared plus 36t. So 3t squared minus 24t plus 36 is equal to 0. How should we solve? Factor. Everything's on one side. I got 0 on one side. Shaggy said factor? Yeah. What GCF could I factor out first? 3. So let's divide everything by 3. Let's keep factoring. What multiplies to make 12 and adds up to be negative 8? 6 and 2, but what signs though? Negative 2 and negative 6. At each factor equal to 0. T minus 6 equals 0 and t minus 2 equals 0. So the particle's at rest at 6 seconds. And is it 2 seconds? And then again for part 2, when is the particle speeding up or slowing down? When is the particle speeding up or slowing down? What would have to be true about velocity and acceleration when the particle is speeding up? Same sign. If velocity and acceleration are both the same sign, either both positive or both negative, it's either gaining speed as it moves away from the origin or gaining speed as it moves back towards the origin if velocity and acceleration are both negative. If they are opposite in signs, slowing down. If velocity is positive but acceleration is negative, it's moving forward, but it's doing so at a slower and slower rate over time. If velocity is negative but acceleration is positive, it's moving backwards, but it's moving backwards more slowly and more slowly and more slowly over time. Does that make sense? So let's figure out the acceleration function. How do I take the acceleration function? Where do I get the acceleration function from? Under the velocity function. So let's differentiate 3t squared minus 24t plus 36. So a of t, the acceleration function, is given as the double derivative, or just the first derivative of the velocity function. So 6t minus 24. The velocity function, we're going to have to compare that here in a second, so let's just write that down again. We got here 3t squared minus 24t plus 36. I'm trying to look at the signs of these two functions. Where are they either positive or where are they negative? Where would they switch signs? Where would the velocity function switch signs? We already know. Why? That's where it's zero. It switches signs when it equals zero, right? Zero is neither positive nor negative, so wouldn't it have to switch signs at these two locations if it does? So I'm going to make a number line for velocity between 0 and 8 seconds. I know it switches sign at 2 and 6 seconds. So we're going to test within each of these intervals to see what the sign of a velocity function is. I know it can't switch sign anywhere between 0 and 2 seconds, or between 2 and 6 seconds, or between 6 and 8 seconds. So I can just plug a number in within those three intervals and see what sign it's going to have to be. Give me a good number between 0 and 2. 1. Let's plug in 1 to the velocity function and see what sign it has. What is 3 times 1 squared minus 24 times 1 plus 36? Would that just be 3 minus 24 plus 36? What would that be for its sign? Positive. Velocity of this particle is positive between 0 and 2 seconds. So I'll just put some plus signs on that part of the number line. Give me a good test value between 2 and 6 seconds. Any number you want between 2 and 6, it does not matter. 4. Let's try 4. Now I might need to grab a calculator here, because we're going to plug 4 in velocity and just see if it's either positive or negative. We're testing this interval and seeing what sign velocity has between 2 and 6 seconds. So 3 times 4 squared minus 24 times 4 plus 36. I get negative 12 when I just quickly type that in my calculator, which means that the velocity has changed signs, and now it's negative for every time value between 2 and 6 seconds. I bet between 6 and 8 we're going to pick 7, right? Let's do 3 times 7 squared minus 24 times 7 plus 36. I get positive 15. So I've switched back to moving in the positive direction away from the origin because velocity is now greater than 0. That makes sense so far? And that's half the story. Now I need to know what the acceleration does. We'll make the same number line between 0 and 8 seconds for this particle in motion. I don't really know where its acceleration changes signs yet, though. How can I figure that out if I didn't know already? Where would acceleration be equal to 0 at? That's velocity. I'm doing acceleration now, Shay. I want to make the same number line to indicate or investigate the signs of acceleration. Where is acceleration equal to 0 at? 4. Why 4? Everyone's saying 4. 6 times 4 minus 24 equals 0. Just set 6t minus 4 equal to 0. And you could just simply solve and get t equals 4. Acceleration is equal to 0 when t equals 4 seconds. Okay, we have 2 intervals to test. I need to think of a number between 0 and 4 and between 4 and 8 to see what the sign of acceleration is for our particle. What's a good number between 0 and 4? 2. Okay. 6 times 2, we're plugging it into acceleration now, just to test to see what the sign is. 6 times 2 is 12, 12 minus 24 is negative. About between 4 and 8, what do you want to plug in now? 6, okay. Really anything works. 6 times 6 is 36 minus 24. It's positive. Okay, let's use those number lines and compare the signs of velocity and acceleration to see where our particle is either speeding up or slowing down. We'll start from 0 to 2 seconds. From 0 to 2 seconds, velocity is positive, acceleration is still negative. So what does that mean? Slowing down. So I'm going to answer as an interval from 0 to 2 seconds. Then what happens?
Speeds up.
Between what 2 times?
2 and 4.
2 and 4. Between 2 and 4, velocity negative, acceleration still negative. Then what happens?
Goes down again.
Slows down again because velocity stays negative, but acceleration goes back to positive. So from 4 to 6, slowing back down again. And then lastly, I think 6 and 8, aren't they both positive again?
Yes.
This particle in motion has these relative speeds, speeding up and slowing down on these intervals. There we go. Now you can kind of see that better. Okay, let me give you guys the rest of class, last 20 minutes or so to finish up that